This video is going to cover Unit 22, Section 3. We're specifically talking about isosceles and equilateral triangles here. Okay? So, the vertex angle is the angle that is opposite the base. Okay? So let's draw an isosceles triangle here. So, let's see here. So right there. So, if this side and this side are the same, I'll just 7 and 7. So, this side and this side are the same. That makes this the base right here. And if this is the base, that makes this the vertex angle. All right? So, to bisect means to cut right in two. All right? And so there's some definitions in here. An altitude is a line segment from the vertex to the base, which is the side opposite the vertex, and it's going to be perpendicular. So if I draw a line from this vertex right here down to the base, and this is an altitude, that means that it's going to be perpendicular, and it also means that this side right here is going to be cut in half. All right? So every triangle has 3 altitudes. So if I were to turn this triangle around so that this was the base, this would be the vertex. And let me kind of draw a little bit of that. I'm not quite sure what this side would be. Let's just say this side was overall 6. That would make each of these 3. So let's draw this with this as the base. So 7 to here, and 7 to here, and then 6 from here to here. So we would have 7, 7, and then 6. Now if I were to draw an altitude at this vertex right here, remember an altitude is going to be perpendicular. So it would be like that. Now in this case, it doesn't bisect this base right here because in this case, this is an isosceles triangle, but we're not talking about the vertex angle being between the 2 equal sides. Over here, the vertex angle is between the 2 equal sides, and it is going to cut, the perpendicular will cut that base in half. Okay, so in an isosceles triangle, an altitude to the base bisects the base and the vertex angle. So that means that this base not only is cut in half, but this angle is also cut in half. So if this whole angle right here were, well, I'm probably not going to get it right based on the sides, but let's say this angle is 40. That means that each of these angles right here will be 20, so it'll cut that angle in half as well. All right, so let's look at let's look at the example at near the top of page 568. Figure 22-37. Okay? So, we're given that AC is equal to BC. That's right there tells me that that's an isosceles triangle. So, the vertex angle is going to be C, and we're drawing it down to the base at point D. So, because this is an isosceles triangle, that means that angle 1 and angle 2 are going to be the same. It also means that the BD segment is all going to be equal to the DA segment. All right? So let's look at example, it's not numbered, but the one all the way to the bottom of page 568 where it's talking specifically about an equilateral triangle. Okay, in an equilateral triangle, an altitude to any side bisects the side that it hits. Because remember, all of the angles in an equilateral triangle are 60. So if you look at figure 22-39, it doesn't matter. They draw the altitude from angle B down to base AC, but it would be the same thing if you use altitude from C down to base AB. If you have an isosceles triangle, and remember, an equilateral triangle is an isosceles triangle, and you draw a line from the vertex down to the base, you're going to be cutting it in half. Now, it doesn't work on this one. This is still an altitude because it's perpendicular, but because this is not between the two sides that are equal, then this is not bisecting either this line right here or this angle right here. They don't really say that in there, but that is one of the stipulations. That has to be between the two equal sides. Now, in the equilateral triangle, since all the sides are equal, it doesn't matter which one of those angles you use as the vertex angle. So let's take a look at some of the stuff on page 570. Okay, let's look at number 7. Number 7, it says determine side A for part A and then angle 1 for part B. So let's look at side A. Okay, so since the whole side, the whole bottom is 9.2 inches, and one side there is 5.9 and the other side is 5.9, that tells me that that's an isosceles triangle. So therefore, they don't label it, but you can see the vertex there and down to the base, and that's perpendicular. So that means that 9.2 is cut in half. So side A would be, let's see, 9 cut in half is 4.5, so that would be 4.6. A would be 4.6. Then to find angle 1, well, since it's an isosceles triangle, angle 1 would equal 38 degrees, 46 minutes. So those two angles would be the same. Okay, let's see. What's another one here? Well, let's just look at number 9. Okay, so part A, we're looking for side C. So let's look down here. Okay, so those two base angles are both 57 degrees, 22 minutes. So therefore, because those two angles are the same, the opposite sides are the same. And since one of those opposite sides is 21.07 inches, that means that C is also 21.07 inches. And then side B, since now we know that that is an isosceles triangle, that means that the altitude coming down from that peak is bisecting or is perpendicular to that base. That means that that base is being bisected. So therefore, one part of that is 11.36 inches, so the other part is as well. So if we add those together, we get 22.72 inches. So side B is 22.72 inches. Let's see if we can find another one that looks interesting. Oh, let's look at number 12. Couple things about number 12 that I know right away. I don't really care what any of those sides are at this moment. I can see that two of those angles are 60. If two angles are 60, I know the other one has to be 60 as well, because they will all add up to be 180. So that right there alone tells me that that's an equilateral triangle. So I don't really need to see any of the sides and stuff, so I know that's an equilateral triangle. So the altitude drawn perpendicular to that base tells me that they don't label it, but that base is going to be 8 inches or 8 feet 3 inches. Because all the sides are going to be equal because it's an equilateral triangle. So side D is, well, let's answer it. So angle 1 will be half 60, so angle 1 is 30. And B says side D, so side D will also be 8 inches, or 8 feet 3 inches. And then side E is half of that, so it will be 4 feet 1.5 inches. All right. So this is isosceles and equilateral triangles specifically. So let's take a look at, before I go, let's look at one more, and let's look at number 8. Determine angle 1. Okay, which one is angle 1? Okay, that's angle 1 right there. So we need to determine that we need to prove that to us that this is an isosceles triangle, and we do that by saying that those two sides, you can see the two sides that are 22.8 centimeters. Because those two sides are the same, this is an isosceles triangle. So therefore, that altitude drawn perpendicular to that base is going to bisect that base. Okay? So, and it's also going to bisect the angle, which is 64.58 degrees. So angle 1 is half of 64.58, which is going to give me, I'm not going to try to do that one in my head. 64.58 divided by 2, 32.29. So therefore, angle 1 is 32.29. And angle 2, so how do we figure out what angle 2 is? Angle 2 is equal to the other base angle, which is to the left of it. And since that's true, we take 180, and we subtract 64.58, and we get 115.42. So the other two angles add up to be 115.42, and they're going to be equal because that is an isosceles triangle, and those are the two angles by the base. So I just simply divide that by 2, and I get 57.71. So angle 2 is 57.71.